All right, so how do you solve now problems on Boyle's law? I'm gonna just, just create this problem, or you know what? I can actually use the example here, guys, in the textbook. Now, let me just see. Okay, so example 12.2. All right, let's solve the problem, guys, in Boyle's law. So you got an air bubble. It forms at the bottom of a lake with a total pressure. So what I'm given here, P1, is equal to 2.45 atmospheres. And at this pressure, the bubble has a volume that would be V1. Now at this particular condition, initial condition. What volume on milliliters will it have when it rises to the surface where the pressure is? So now this is my P2, and that will be now 0.93 atmospheres. Assume that the temperature remains constant, as does the amount of gas in the bubble. Now, here's the thing that I forgot to mention with the Boyle's law. When I talked about the P times V is equal to K, it is absolutely at constant temperature and number of moles, and N, guys. So I forgot to mention it, so just be aware, guys. Now, so this bubble, of course, the number of moles don't change until the bubble bursts, of course. So that's right there. You're going to have, guys, the same number of moles where the bubble originates at the bottom of the lake and then goes up to the surface of the lake. Now, the temperature, of course, well, you have to assume it's the same, although in the real life, at the bottom of the lake, the temperature will be lower usually. Okay, but anyway, so they mentioned about the temperature constant, number of mole constants. Now my life is much easier. So let me just explain you something, guys, how to solve these problems. Now, when you have P times V is equal to K, let's say this is P1, this is V1, it's equal to, to this constant. Now, what happens if I now increase the volume? I'm going to create a V1, and of course, or let's say I'm going to increase, let's say, the pressure. All right, let me just do it the consistent way. Now, let's say I'm increasing now the pressure. I have some P2. Because the product of the two is the constant, if I increase the pressure, I must decrease the volume to now figure it out to figure out this volume. And the trick here is realizes that the product of the pressure volume is always a constant. So even if I change the pressure, if I increase, for example, the pressure, I will decrease proportionally the volume so that when you multiply these two terms, you're still going to get the same constant as here. These are the same constant. So what I can say now here is that P1 times V1, see, I'm saying one thing and I'm writing something else, is equal to P2 times V2. And that's the way to solve these kind of problems. Now, what's given here is definitely the P1. What's given here is the V1. What's given here is the P2. All you have to find is the V2, which will be P1, V1 divided by P2. All I have to do now, plug the actual values in, 2.45. And let's now conceptually now predict what's going to happen to the, to the volume V2. Look, I went from higher pressure to lower pressure. So if my pressure here decreases, my volume now must increase according to the Boyle's law. Let's see if we're going to get a bigger volume than 3.1 ml. So let's do it. So 2.41 times V1, which is 3.1 ml, divided by the P2, which is 0.9. Oh, forgot to put the units here, guys. This is atmospheres. 0.93 atmospheres. Canceled. All right, so I'm getting, guys, the right units. That means I set up everything correctly here. And so now I'm going to use my calculator to figure it out now, the final answer. And so I'm going to do now 2.45 times 3.1 divided by 0.93. Since I got only two significant figures now in this particular P2 now, my final answer, guys, has to be now two significant figures according to the rules, right? So it's going to be 8.2 ml. And that will be the final answer. And that actually is consistent to what we predicted. Once the temperature, guys, dropped, the volume had to increase from the original 3.1. And that's where you guys, you see now the volume, new volume is 8.2. Because now if you're going to take 8.2, now times this 0.93, you're going to get some constant. And if you guys are going to do the same now thing for this one, 2.45 times 3.1, you're going to get, you guys are supposed to get the same constant. And that's why I equated now these two, because the mass equal to the same constant. All right, guys, I'll see you in the next video. I'm going to go, guys, into the Charles or Gay-Lussac law. I'm going to do some problems also to demonstrate how to solve those problems for different gas laws.